Hello children, welcome you in this session. As already I have explained the definition of continuity and the different conditions of continuity. So now let us move to your problems. This is page number 149 of your book NCERT. I will explain first example. The example is if x is equal to 2x plus 3 at x is equal to 1, check the continuity of this function. Check the continuity of the function if f(x) is given as 2x plus 3 at x is equal to 1. Children, you know that what you have to do. You have to find the three conditions because this is point continuity. You have to find the three conditions. What conditions? Limit of the function. Let us calculate limit of the function. Limit x tends to 1 fx. I will write limit x tends to 1 in place of fx. What do I have? 2x plus 3. So please write here x is equal to 1. This I will get 5. Now let me calculate left hand limit. Left hand limit is LHS. Limit x tends to 1 minus fx. I will write limit x tends to 1 minus h tends to 0. This is 2x minus plus 3 and limit x tends to h. Now h it is limit h tends to 0. This is 2 into 1 minus h plus 3. In place of x, जहाँ पर x है वहाँ क्या लिख देना है? 1 माइनस h लिख देना है और बाकी रिमेनिंग जो एलिमेंट्स होंगे जैसे 2 यहाँ पर था तो यही आएगा और प्लस के बाद 3 है तो एज इट इज यू विल राइट इट. नाउ दिस इज लिमिट x टेंड्स टू h टेंड्स टू 0, 2 minus 2h plus 3. This I can write 0 because this is not going to make my function undefined. If anything is not going to make my function indeterminate, so I can write its value 0 very easily. This is again 5. And when I go to RHS, this is limit x tends to 1 plus fx. And again the very similar conditions I am going to apply over here. H tends to 0. This is 2 into 1 plus h plus 3. Again I will get 5. Now look here. What do I have? I have LHL is equal to RHL is equal to limit of the function. These three are equal. So this function is continuous. I can say at x is equal to 1. This function is continuous at x is equal to 1. So very easy result I can get a linear expression. This is a linear expression. A linear expression I can say is always continuous because see, when I draw the graph of this 2x plus 3, this is a straight line. This is a straight line with slope how much? 2. You can draw this graph. You can draw this graph very easily this way. This will always be continuous whether I go downwards or I go upwards. Without lifting my hand, I can draw a straight line. So this is always continuous. What conclusion I got from this? The conclusion is a linear expression is always continuous. Now let us move to this second problem. What is the second problem here? It is fx is equal to x square, a quadratic polynomial. This is a quadratic polynomial. Second question I am talking about a quadratic polynomial. First question I had a discussion of a linear order polynomial. If I write this, again the same thing, I can calculate limit of the function. Limit x tends to 0 fx. I can write limit x tends to 0 x square, this is 0. And left hand limit, let me calculate left hand limit. Limit x tends to 0 minus fx is what? Limit h tends to 0, x tends to 0 minus h. This is 0 minus h whole square, again h square and 0. Similarly, right hand limit also I will get 0. So what do I get? Left hand limit is right hand limit is equal to limit of the function. Hence, this function is also continuous. So, what is the conclusion? The conclusion is a quadratic polynomial always continuous everywhere. Do remember these all, because in while doing differentiation applications, we need all these results. Where there I am not going to solve all this. This total solution will not do, but we will use these results. So now let us move. I will do some more examples from here. Children, are these two examples clear to you? Try to understand the examples, because I am moving to the next. It is now this kind of function. If x is equal to x cube plus 3 when x is not equal to 0, and this is equal to 1 when x is equal to 0. This is called a biconditional function. Here are two conditions. So what are the two conditions? When x is equal to 0, then if x is not equal to 0, then fx is equal to x cube plus 3. And when x is equal to 0, fx is equal to 1. So again, what check continuity at x is equal to 0 means same. We have to calculate left hand limit, right hand limit, and limit of the function at x is equal to 0. Let us see what happens. If I write its left hand limit, try to understand x is not equal to 0. X is not equal to 0. What is fx? Fx is x cube plus 3. Fx is equal to x cube plus 3 when x is not equal to 0. Means I will calculate left hand limit and right hand limit at this function, at fx is equal to this. I will take fx is equal to x cube plus 3 while calculating left hand limit and right hand limit. Let me calculate left hand limit. Limit x tends to 0 minus, this is left hand limit. Fx is equal to, I will write limit x tends to 0 minus h tends to 0, I will write x cube plus 3. Alright. This is now limit h tends to 0, 0 plus h whole cube plus 3. What is this? This will come as 3. Let me take RHS. RHS is limit x tends to 0 plus fx. Again I will write the same thing. Limit x tends to 0 plus h tends to 0. This will become 0 plus h whole cube plus 3. Again this will be 3. Right hand limit is also 3. Left hand limit is 3. Right hand limit is 3. And what is limit of the function? I am given. This is given to me. Fx is equal to 1. This is given to me. Now left hand limit is equal to right hand limit, but this is not equal to limit of the function. So this function is not continuous. This kind of discontinuity is called non-removable discontinuity. Furthermore, one more example is here. Let me discuss this example. If I come to this example, this is very important. See, look here. At what point it is not given here. So I can take any point from its domain to see this, to check this, because I am not given the particular point. In previous questions, I was given the point. Now this kind of continuity is called interval continuity or domain continuity. I will check whether this function will be continuous in its domain or not. Because see, what is its domain? Its domain is r minus 0. You know this. And x is not equal to 0 we are given. So very easily I can take any point. Let us take any point in its domain. C belongs to DF. I will take any point C from its domain, and at this point C I am going to calculate its left hand limit, right hand limit, and limit of the function. let me see about its limit, left hand limit. I write limit x tends to c minus fx. This is equal to limit x tends to c minus h tends to 0. This is 1 upon x. Limit h tends to 0. This is 1 upon c minus h, 1 upon c minus 0, 1 upon c. Exactly same way, when I write limit RHL, limit x tends to c plus fx, I will get 1 upon c. And limit of the function, if I calculate over here, limit of the function, f this tends to c, fx is equal to 1 upon c. These three are equal. Left hand limit, right hand limit, and limit of the function are equal. So this function is continuous within its domain. Alright, now you will move to your exercise 5.1.